Okay, let's have another look at these definitions of injective and surjective to see if we can understand how the formality matches up with the idea. So in this first one, injective, the idea I said is that nothing on the right gets hit more than once. And what this definition is saying, so hit means what happens when you do F to something. You start with some point over here, you do F to it, and it goes over there. So what this is saying is, supposing we had A1 here and A2 here, we do F, and they've both landed on the same point. And so what we're saying is that's not allowed unless A1 and A2 were actually the same point to start with. So this is saying if you ever get a situation where A1 and A2 land in the same place, that's only allowed if A1 and A2 were actually already the same. So that's what this is saying. Okay? And then the surjection definition is saying, supposing, wipe all that off and start again, this is saying everything on the right gets hit. So let's just look at an arbitrary point B on the right-hand side. I want to know it gets hit by something. I don't care how many times it gets hit, but I do care that it gets hit at least once. So remember, this means for all, this little symbol here, and this means there exists. And if you want to show that if you want to look at something that's true for all B, you pick a random one. Because it was random, it'll work for any B. So we pick a random B on the right-hand side and say, okay, I want there to exist some A in the left-hand side such that when I do F to it, it hits B. Right? So we say everything gets hit. Everything has to be hit by something. So there has to be a point over here that hits the B. So that's what surjective means. Right. So now let's have a look at some examples of things and see whether they're injective or surjective or neither. Okay. I'm going to leave the definitions up and do my examples down here. So we already did the first example. I gave you a list of examples of functions in the first two functions videos. So I'll go through those again now and have a look at whether they're injective and surjective. Right. Now the second example I gave had A being 0, 1, 2, and 3. And B being the set just containing 0 and 1. Okay? And what I said was that F of A is going to be the remainder when I divide A by 2. The remainder when we divide A by 2. And if you know about modular arithmetic, or if you've watched the modular arithmetic videos, you'll know that what this means is we're going to take A mod 2. So it's A mod 2. And the point is that if we look at where 0, 1, 2, and 3 go, then 0, if we divide it by 2, it goes exactly, so there's no remainder, so 0 goes to 0. Whereas 1, if we take that mod 2, we get 1, because the remainder, if we try to divide it by 2, is 1, because it doesn't go exactly. Right? Now 2 is divisible by 2, obviously, so the remainder at that time is 0. Whereas 3, the remainder is going to be 1. 3, if we take it mod 2, is 1, because 2 doesn't go into it exactly, there's always going to be 1 left over. So if you look at this diagram here, you see that 0 and 2 both went to 0, and 1 and 3 both went to 1. So let's have a look. Injective means that nothing on the right gets hit more than once, whereas here, everything on the right got hit twice. So this is not injective. Okay? Now let's look at surjective. Surjective means everything on the right gets hit. And let's have a look. Yeah, everything on the right did get hit. So this is surjective. So that deals with that example. Now, more generally, we could do this for doing the integers mod n in general for any n, and we would get something very similar. So if we did, let me just wipe that out to make a little bit of space. We could also do a being all the integers, b being the integers 0 up to n, and we could say that f of a is a mod n, which means the remainder that you get when you try and divide a by n. In which case, what's going to happen? It's still not going to be injective. How do we show that something is not injective? We have to show that somewhere at least two things get sent to the same place on the right. So let's have a look. Well, definitely f of 0 is 0, because the remainder when you divide 0 by n is 0, but also f of n equals 0, because the remainder when you divide n by n is also 0. So here I've shown you two things on the left that get sent to the same place on the right, so this is not injective. Just like in this case it wasn't injective, but it is surjective, because everything over here gets hit at least once by, well, the same number over here. So that's the more general situation for this one. Okay, so the next one we had was multiplication by 2. Right, so this time, the next one we had it was still 0, 1, 2, and 3. And this time b is 0, 2, 4, and 6. And f of a is going to equal 2a. So if we draw a picture of this, 0, 1, 2, and 3, and over here we've got 0, 2, 4, and 6, then 0 times 2 is 0, 1 times 2 is 2, 2 times 2 is 4, and 3 times 2 is 6. There. Isn't that pretty? Everything's lined up. Everything goes to only one place, so there aren't any two things on the left that go to the right, and everything over there gets hit. So this is injective, and this is surjective. And you'll notice that this makes a very pretty correspondence. There's a very pretty correspondence between the things on the left and the things on the right. They match up perfectly. And so things that are both injective and surjective are particularly nice. And that's called bijective. So something is bijective if it is both injective and surjective. And perhaps I'll write that up next time.